Hello, everyone. The topic today is isotope. Isotope. But before we start, let's review the periodic table. Okay, let's review the periodic table again to emphasize few things you must know before we continue with this topic. And the periodic table, we know that these elements are arranged in order of the atomic number. This is the key. With this key, you can understand about every information of each element in the periodic table. The number on top is the atomic number. This is the element symbol. Then this is sodium, the name of the element, and then the average atomic mass. Note that atomic number is also the number of protons. Atomic number is the number of protons. And every element in this periodic table is neutral, meaning that the number of protons is equal to number of electrons. Okay? And let's also look at this simulation. Okay, we already looked at simulation before, and we're looking at it again. Okay, let me build an atom. Before I continue, I want you to focus here. By focusing here, when I'm done, I'll ask you what you think the meaning of this here is and what this is, and also what this means, okay? I'm building an atom. Remember, in building an atom, there are 3 subatomic particles that is used in building an atom. We had the protons, neutrons, and electrons. And we also looked at their characteristics, okay? So we are building a lithium atom, which is a very small atom. So I'm building a neutral atom. This is a neutral atom. Okay. From this, pause the video and think about what you observe. What do you think this is? This number 7 means what? This number 3 means what? This 0 means what? Pause the video. Okay, hopefully you thought about it. 7 means mass number. That is total number of protons and neutrons in the nucleus. That's where that came from. If you count this, you count a total of 7. There are 3 protons and 4 neutrons that make up this number 7. This is mass number. And then this number means the number of protons. Number of protons. There are 3 of them. And this 0 means that this is a neutral atom. The net charge is 0. It has no charge. Remember, we use Bohr model. This is called the Bohr's model because it's convenient. We can see everything we want to see, and everything that is happening can easily be explained. But this is the modern atom. This is where the modern atom looks. We don't use it because we don't see, like, you can see the electron here, okay? So we have to know this to continue. If you look at this, you find that it's similar to what we just looked at in simulation. This is the mass number. A is the mass number. Z is number of protons, which is the same as the atomic number. Okay? And we call this isotope notation. Okay? Isotope notation. Remember, mass number is the sum of the number of protons and neutrons. Okay. This is, when we look at periodic table, this is what we saw. This is periodic table notation. periodic table, this number is the atomic number. Then you have the symbol, you have the name, you have the average atomic mass. And then here, this is the isotope notation or nuclear notation. This means the mass number, this is the atomic number or number of protons. Let's compare the two sodium atoms. Let's compare both of them. You can pause the video, think about it. Compare these two, and what can you conclude about it? Okay, here, let's compare. Both of them have number of protons, 11. That's why they the same atom. That's why they have the same name, because number of proton is unique to each element. Then here, the mass number is 23. The mass number is 24. Okay. The number of neutron is here is 12. Here is 13. How did we get the number of neutrons? Let's look at it again. So you have, we know the mass number is sum of the protons and the number of neutrons. Yes. So if we know that this sum of these give you the mass number, then how do we figure out the number of neutrons? We can figure out the number of neutrons by using this mass number minus number of protons. And this mass number is different because the neutrons and the number of neutrons is different. The number of neutrons is different. Therefore, this is isotope. These two of these are isotope because it's isotope because it has the same element, which means it has the same number of protons, but different number of neutrons. Okay. So these are examples, more examples of that. You see, here it says carbon 12. This hyphenated notation, this is hyphenated, is telling us this is mass number. This is mass number. This is mass number. Here we know the mass number, but we are not given the number of protons here. So how do you figure out the number of protons and neutrons? You go to the periodic table, look up carbon, then you see the number of protons. And then if you know the number of protons, you can know the number of neutrons. Here, in this isotope of carbon, you see why is isotope, the neutrons, number of neutrons are different. Okay. This is another isotope here. The isotope notation is used this way. You see, number of protons that are the same, but the mass number is different because the number of neutron is different. Here, there's no neutron, there's one neutron, there's two neutrons. Okay, so again, this is isotope. So what is isotope? Isotopes have the same elements, which is the same number of protons that have different number of neutrons. Atoms of the same elements, that is the same number of protons that have different number of neutrons. Okay, that's what isotope is. To have a very good understanding of isotope, I would like you to watch this video. It will really make it clearer.
What are isotopes? Isotope is a word that gets thrown around in chemistry a lot. So what are they? Really quickly, isotopes are different versions of an element or different versions of a certain kind of atom. This can be a tricky concept though, and a lot of people get confused by isotopes. So I want to describe them by starting out with an analogy to cars, okay? I want to talk to you about the made-up car called the Lamona, the epitome of luxury, and it's known for its very distinctive styling. As you'll see, the Lamona looks like a lemon. Now, the Lamona comes in 3 different models. There's the Lamona G, the Lamona GX, and the Lamona GXL. They're all different colors, as you can see, but each of these models also has unique features. One has a radio and leather seats. The GX here has chrome wheels and a CD player. It's blue. The red GXL has massaging seats, platinum spinner wheels, and everything. But here's the point. They are all Lamonas. They're all Lamonas because they all have this distinctive styling. They look like a lemon, and that's what makes a car a Lamona, okay? So it doesn't matter what color it is, and it doesn't matter the various options that you get in these models, the GX or the GXL. What matters is that they all have this particular shape. That's what makes a Lamona a Lamona. So we have these three different models. I want to use this analogy now to talk about the same thing but with atoms. I want to now introduce you to three models of carbon, just the way there are three models of the Lamona. Okay? Here are the drawings of each one of them, and what we're particularly concerned about is the nucleus. I'm using these red dots to symbolize protons, and I'm using the blue dots to symbolize neutrons. The swirly circles are supposed to represent electrons that are buzzing around the nucleus, but we don't really want to worry about that too much right now. Anyway, these three models of carbon are carbon-12, carbon-13, and carbon-14. Let's look at the options in them. Like we did with the Lamona, let's look at how each one of these different types of carbon differs. Okay? So, if we count the number of protons in carbon-12, we'll see that it has 6 protons, and if I count all the blue spots here, I have 6 neutrons. Okay? Carbon-13, 1, 2, 3, 4, 5, 6. Red spots, 6 protons. In this one, I have 7 neutrons. And in carbon-14 down here, I have 6 protons, and I have 8 neutrons. So what do we have in common here? All the different models of the Lamona, even though there are things that they differed about, all have the same distinctive lemon-like shape. So for carbon, what they all have in common is they have 6 protons. 6 protons in the nucleus. And that's what makes a carbon atom a carbon atom. Okay? So it turns out that it doesn't matter how many neutrons it has. 6 neutrons, 7 neutrons, 8 neutrons, no big deal. It's just like painting the Lamona different colors or adding a radio or a CD player. The neutrons, it doesn't matter. It doesn't change the fact that each one of these are a carbon atom. That's because carbon is defined by the fact that it has 6 protons in its nucleus. If you look it up on the periodic table, you'll see something that looks like this, and the number up here is the atomic number, 6, which means that if an atom has 6 protons, it's carbon. Okay? So that's what these all are. They are all isotopes of carbon. They're different versions of carbon or different models of carbon with the same number of protons and different number of neutrons. So look at how I wrote this. I've got carbon-12, carbon-13, carbon-14 up here. I want to take a minute and talk about the numbers. So the number of protons in the nucleus, we call that the atomic number. You may already know that. And then carbon-12, this 12 that I've written here, refers to a different number, and we call that the mass number. The mass number, as you'll see, is the number of protons plus the number of neutrons. So this is carbon-12. 6 plus 7 protons and neutrons is 13 here. 6 plus 8 is carbon-14 here. So that's how we distinguish between these different isotopes, different types of carbon. There's another way that we sometimes indicate these different isotopes of an atom instead of doing 12 and 13 or 14, and that's by using something called isotope notation. Let me show you how we do that. The way we write carbon-12 or 13 or 14 in isotope notation is we start out with a chemical symbol. If you don't already know that, you can find it on the periodic table. So here it is. It's a big uppercase C. So I start with my C for carbon. And then on the lower corner here, I write the atomic number. So that's going to be 6. And then up top, I write the mass number, which is 12. So this is carbon-12 written in isotope notation. Carbon-13 is going to be 6 again, because all carbon has 6 protons in its nucleus. But then the 13 up here. And finally, Carbon-14, written in isotope notation, is C614. So that's how we can write all these isotopes of carbon in isotope notation. And of course you can also write it as just the element name with a dash and then the number. So carbon isn't the only type of element that has multiple isotopes. In fact, just like cars, almost every form of element comes in multiple isotopes. Here are the calcium isotopes, for example. If you look up on the periodic table, you'll see that calcium has an atomic number of 20, which means that any atom that has 20 protons in its nucleus is calcium. But just like with carbon, you can vary the number of neutrons that are in the nucleus. You get all these different isotopes, but you still have calcium. Calcium, we've got 40, 42, 43, 44, 46, 48. All of them have 20 protons in the nucleus, but they have varying numbers of neutrons. Just like we did with carbon, we can write all of these calcium isotopes in isotope notation, where we have the mass number here up at the top, and the atomic number down at the bottom. You'll see they all have the same atomic number of 20, but different mass numbers, the sum of protons and neutrons. The same is true for iron, just to give you another example. Iron has 26 protons in its nucleus, an atomic number of 26, and there are 4 known isotopes of iron, all of which have 26 protons in the nucleus, but they all have varying numbers of neutrons. You add these together to get the mass number, and then you can write it in isotope notation with a mass number up here and the atomic number down here. So just to review what we've talked about, atoms come in different versions known as isotopes. These are like the different versions of a car or something. The number of neutrons change, but just as long as you have the same number of protons, you still have the same type of atom, the same type of element.
I hope watching the video has helped you a lot in understanding the isotope. So now I'd like to answer these questions. Practice questions. If you're able to answer these questions correctly, it means you have good understanding of this. So pause the video and then answer these questions. Then this is the answer to the question. This last one, drawing, use drawing to show. Okay. Draw the atom and write the isotope notation of the element. Okay, you draw the atom. Then this is the isotope notation. Okay. Then this is another question. Pause the video. You just need to fill in the blanks. Assume all atoms are chromium is neutral atom. Again, fill in the blanks. Pause the video. Then here is the answer to that. Hopefully, this makes sense. Thank you for watching.